Hi there, folks. Today we're looking at using corresponding parts of congruent triangles. So we've been looking at proving that triangles are congruent. Now we're going to talk about if they're congruent. We can talk about all the different pieces that are congruent. All right. So if we know the two triangles are congruent, then the corresponding parts of those triangles are congruent. And we abbreviate it this way. We call it CPCTC. All right. If you've ever heard that abbreviation before, ever heard other students mention it, it stands for corresponding parts of congruent triangles are congruent. Okay. Corresponding parts of congruent triangles are congruent. All right. And it's just a nice way to summarize this idea that, hey, if I have two triangles that are the same, that are congruent, then all of those different corresponding pieces are congruent. All right. For example, if I look at something like this guy, we're going to start with a proof, all right? See, before we were just proving that the triangles are congruent. Now we want to specifically say that two pieces are congruent. So the approach doesn't change. We're going to start by trying to show that the triangles are the same. And then after we say the triangles are the same, we can say that the pieces are the same based on CPCTC, okay? So if I look at something like this guy, I've got that angle BAD and angle DCB are congruent. So angle BAD, that's this guy, and angle DCB, those are congruent. I'm labeling them on the picture. Angle ABD, that's this guy right here, is congruent to angle CDB, which is this guy right here. And now I want to prove that segment AB is congruent to segment DC, all right? And so here's the thing. If I wanted to prove that AB and DC are the same, well, I would know right away that they're the same if I could show that these two triangles are the same, all right? And so that's the path that I take. I want to show that the triangles are the same so that I can show that the different pieces are the same, all right? So here we go, statements and reasons. I just start with what I know. So once again, so I say that these angles are congruent, and I know that because it was given. So now as I think about this thing and I think about showing the two triangles are the same, there are two options that I can use with angles. There was angle side would prove that the two triangles are congruent, or angle side angle. And so as I look through here, both of those involved a side being used. So as I look at these two triangles, are there any sides that I can show to be congruent to a side in the other triangle? All right. And once again, it's that idea that they are sharing one of the sides. And so the side they share has to be the same for each triangle. It's this one cutting across the middle here, okay? BD. And see, BD is in both triangles, which means that BD is congruent to itself, helps us because it shows us one side of each triangle is the same. And that's my reflexive property. And so now from here, I have two angles and a side. I just have to decide what version of this thing do I have? Do I have the angle side angle or angle side? And again, it's about looking at the angles and working your way across. So here's an angle. As I work my way across the triangle, I run into an angle next and then into a side. Same thing with the other one, starting at the same angle, and then I run into this side. And so the idea here is the two triangles are congruent because of angle side is the way it's listed, all right? And also be careful with your labeling here. I always start with one and just label it. So like A, B, D would be one triangle. And so as I go to label the other triangle, I'll just have to look and say, okay, A matches up with C. But now think about B. B actually matches D in the other triangle in terms of the positioning of that angle that's congruent to that first triangle. And then the last one we have left is B, okay? So triangle ABD is congruent to triangle CDB, and we know that because of angle side as we kind of listed it. But now because the triangles are the same, I can say their corresponding pieces are the same. See, once I know the triangles are congruent, I can say the parts of those triangles are congruent. So now I can say that this guy is congruent to this guy, okay? Segment AB is congruent to segment DC, and that's because those are the corresponding pieces. And my justification, I can just use that abbreviation, the CPCTC. Corresponding parts of congruent triangles are congruent, all right? And if you want to write that out in a sentence in some way and just say, hey, if two triangles are congruent, the corresponding parts are congruent. All right, you could literally list it that way. The CPCTC thing is just a nice abbreviation that saves us from having to write this over and over again. Okay? If I look at something like this guy, same kind of thing. I want to prove that these two pieces are congruent, that angle E is congruent to angle D, and the route that I'm going to take will be using congruent triangles to show that the parts are congruent. So once again, statements and reasons here. I start with what I know, and I'll label it on the graph here as I go. AB is congruent to CB, so AB is congruent to CB. EB is congruent to DB. That's this one right here. And I just want to prove that angle E is congruent to angle D. So let's write down what I've marked on my figure here. The AB congruent to CB. And again, that was given. That's why I marked it on the graph. And so now from here, I have two sides that are congruent. So think about proving the triangles are congruent. We had side, side, side. That involved two sides. We had side, angle, side, which involved two sides. And so as I look at this thing, is there any way that I could show that AE and CD are congruent? And if not, I have to start thinking about the angle that I have. And remember, if I want to use side, angle, side, I need the angle in between, which is this guy right here. And so I think about what I have, what I need, and now I look at what I have. Well, can I say that those two angles are congruent? And the answer is yes, because what kind of angles are those? Okay? So yeah, angle AB is congruent to angle CBD, and that's because those are vertical angles. Okay? That's a terrible looking angle symbol. It's not sharp enough, right? It had too much curve to it. Boom. That looks good. Okay? And so now if I have these two angles are congruent, I have side, two sides in the angle between, so side, angle, side, I can say that the two triangles are congruent. And again, I always just list one of them, so I'll say triangle ABE, so triangle AB. And so kind of match it up in terms of the pieces. A matches kind of with C here, so it's C, then B, then D for this one, okay? And that was because of side, angle, side. And now the last piece of this thing, I don't want I needed the two triangles to be congruent, but now what I'm trying to find is that the parts are congruent. So now I can say that angle E is congruent to angle D. And I know that because CPCTC, corresponding parts of congruent triangles are congruent, okay? So it's really the same thing that we've been doing with one added step. Instead of stopping with the triangles being congruent, I'm now moving a step further and saying, hey, if they're congruent, I can talk about the different pieces being congruent, okay? If I look at this next guy, it says given AB is congruent to AD, so let me mark it over here. So AB is congruent to AD, and C is the midpoint of DB, so C is the midpoint of DB. I want to prove that triangle ACB is congruent to triangle angle ACB is congruent to angle ACD, all right? Now, again, I'm going to use congruent triangles to get there. So here we go, statements and reasons. Everybody loves a good two-column proof. It's our favorite. And so I start with what I know. And yeah, I'm abbreviating a little bit. Nobody likes to write too much, especially in math class. And so now from here, I just have to figure out, okay, what else can I say here? Right now, I only have one set of sides, so it's kind of up in the air whether I'm going to use side, 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 or side, or angle, angle, side, or angle, side, angle. All right, so think about what else I know here. The other thing that I immediately know is if C is the midpoint, what does that tell me about that segment BD? All right, and hopefully you remember that the midpoint breaks this into two congruent pieces. So now I could say that CB, segment CB, is congruent to segment CD. And that's the definition of the midpoint. That's what the midpoint tells me. Okay? And let me label that on the graph. So these guys are congruent. Okay? And now from here, I have two sides. So that means I'm looking at maybe side, 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 or side, angle, side. And so as we think about those two things, side, side, side is really easy to do here because the only side that's left is AC. And you see that both triangles have AC, all right? Both of these little triangles. So that's the route I would go here and maybe say, oh, well, AC is congruent to AC. It's congruent to itself. That's my reflexive property. Okay? And so when I'm looking at this guy, I can now say that the two triangles are congruent because of side, side, side. And in fact, let me label that over here already. That side's congruent to itself. So now I have all three sides matching up in some way. So I can say that triangle. And again, just label the first one. So I call it ABC. Now as you label the second one, make sure it matches. So it's got to be A and then connected to D and then C to kind of put this in the appropriate order. And again, the reason there was side, side, side. So now from here, if I know the two triangles are the same, it means that the corresponding pieces are the same. So I could say that angle ACB is congruent to angle ACD. Okay? And I know that ACB being congruent to ACD because CPCTC. So again, same kind of stuff we've been doing, but now that I know the triangles are congruent, I'm taking it one step further and saying, oh, now the pieces are congruent. How about this one? And something like this, explain how you could determine the distance from the lighthouse to the boat. All right. And here's the thing. I don't want to go for a swim with a tape measure. All right. Let me start by saying that. I don't want to have to swim out to this boat with a tape measure in order to take this measurement. All right. And so I have to find out a different way to do this. I want to stay dry. All right. And so as we look at this thing, maybe I would look at this and say, okay, let's draw it as a triangle. If you look at something like this guy, I'm up here in this lighthouse. I'm looking down at this boat. Sorry, I should go probably to the edge of the boat, right? And I want to measure this distance, okay? And so the idea here is I want to take these measurements somewhere where I'm not going to get wet, where I don't have to swim out to a boat, all right? So it would be nice if I could take that measurement over here somewhere. All right, and the idea is kind of creating or constructing a triangle that is congruent to the one that's out there on the ocean. All right, and the thing I know for sure, or that should be true here, or we can assume is true, is that right here this is a right angle. All right, hopefully this lighthouse is running straight up and down. It's not the Leaning Tower of Pisa. All right, this is a right angle. It was constructed properly. We can hope. All right, so it's not going to fall down. So I know that that's a right angle, so that's perpendicular. So I want to construct the same triangle over here. And so as I think about this, I got to think about what I have control over. I know that this is going to be a right angle, all right? And so to construct the same triangle over here, all right, there's a couple things that I can't do. I can't just say, well, I'm just going to measure out the same distance right here to ensure that this is the same, because I don't know what this distance is. So I have to think about from the perspective of a lighthouse, all right, what could I ensure is the same? And I certainly can't say that this is the same, all right, this side right here, or this side, Because how in the world am I supposed to know those are the same? And how am I going to measure that? All right, am I going to grab a hang glider and jump down with a tape measure? All right, again, that's not a feasible approach. One thing I do know is that the distance here, the height of the lighthouse, will not change regardless of which side I'm on. So the height of the lighthouse is congruent to itself. All right. The other thing that I can measure from the perspective of the lighthouse is I could measure this angle right here, okay? And see, I can measure that angle from the top of the lighthouse because I can strike out a horizontal line from the perspective of the person in the lighthouse, and I can measure downwards to see at what angle do you see the boat. And there are tools that can be used to do that. You could also kind of give this an estimate, all right, and then transfer that angle over to the other side, all right? But there are tools that do that. Surveyors use them all the time in order to measure elevations and that kind of thing. But when we look at something like this guy, we can measure that angle, all right? From a horizontal line looking straight out from the lighthouse, we could measure down to determine the angle at which we see the boat. And see, that would give us this measurement right here. Of this angle. We could then duplicate that same measurement over here and mark something on the ground, or have somebody else mark something on the ground, maybe put like a little stake in the ground right here, measuring at that same angle, all right? And so the idea here is using the tools that we've been discussing, using congruent triangles to come up with a measurement of distance here. And really, maybe I could look for a landmark that's on the ground somewhere. Maybe it's a rock or a tree or something like that if I don't have another person to work with, okay? Even if I find something that's close by, it's going to give me an estimate at how far away this boat is, all right? But the idea here is that I'm creating a situation where these triangles are congruent because of angle, side, angle, okay? And so now I have these two triangles congruent, and this is a much easier measurement to take right here. The distance across the bottom edge of this triangle is much easier to take because I'm on dry land, okay? I can take that measurement, and that measurement will be the same as the measurement over here. These two pieces will be congruent because the triangles are congruent. All right? And so we want to start to think about those things. This is how we measure great distances across things. Like I can measure the distance across a street without ever crossing the street, just using landmarks and measuring things from one side. Okay? And so it's this kind of neat concept that's used in a bunch of different aspects of different careers, like surveyors use this kind of stuff all the time to measure great distances from a single location. Okay, or from locations that are easier to attain, to get to, all right, instead of having to swim out to this boat. And so when you look at this question, it's really just kind of thinking about how we can use congruent triangles and the parts of those congruent triangles to do different things in terms of measurements that maybe wouldn't be very easy without some of these strategies, okay?